any questions or concerns about the way that your exam was graded, if you have a feeling that maybe there's an error that's made on your exam, please reach out to me or to Morgan, and we will resolve the issue or whatever it is. We work pretty hard to make sure the exams are graded uniformly. We do that by having everybody grade the same question at the same time. So there shouldn't be any cases where one person had one thing and another person got a different score for the same thing. So if you see that by comparing your exam with somebody else, then let us know, because your scores should be identical for the same kinds of mistakes. Okay. Breaking, continuing, and the other kinds of loops. So last time we saw how loops can assist in automation. We saw this prime factorization technique here. And we saw how we don't always want loops to run to completion, and we can cause those loops to stop using the break command. The most important thing to know about the break command is that when you hit the break command, it only leaves the closest or the most tightly nested loop that contains the break. So if this break is contained within this while loop, then it breaks immediately out of the while loop and runs the first command after that while loop. If there's another loop outside this, the break does not affect the exterior loop. Okay, so there are some situations that are unusual, like you have loops that appear like they're infinite loops, like this loop that says while true, but because of the presence of the break, this loop runs exactly once. And we also have examples where a loop has conditions that appear to cause them to end in a finite amount of time, but because of the way the loop iterates, they don't. So this iteration has I increasing each time, but each time it hits 4, it gets reassigned to 0, causing it to continuously never hit 5, and thus run forever. So you can have examples of infinite loops and finite loops that don't look at all like what we might assume an infinite loop looks like, and what we might assume a finite loop looks like. Okay, so one thing that we haven't had a chance to talk about is the continue statement. The continue statement is very much like the break statement, except that rather than leaving the loop, it causes the loop to run to its next iteration. So this is a copy of my prime factorization code where, again, I'm going to have my factor and I'm going to increase my factor as I go from 0 to the input value. And basically I'm going to see if it's a multiple of input value. The only difference is that I've added this if line, which covers the case if my factor is equal to 0. If it's equal to 0, we'll just iterate and then continue. And what continuation does is cause this code to run back to the conditional part of the while loop. So rather than running the rest of this loop, it's simply going to immediately ask again, will this loop run again, and then run the loop again if that's true. So that's different from the break, because the break will leave the loop altogether. The break does not cause you to evaluate the conditional again. The break simply ends the loop. The continue evaluates the condition again and then runs again if that's still true. And that's useful if you want to have the loop skip code that it would normally run. So in this case, by having this continue here, you never run this second if statement, which requires you to perform this modulo operation. So there's less calculation being done because of this continue statement, which skips the case where a factor is equal to 0. And that's particularly important because when my factor is equal to 0, input value modulo my factor is always equal to 0. It sort of skips the work. And this is kind of a trivial example, but there are other cases where having continues saves a tremendous amount of time. If the work being done in the rest of the loop is actually time-consuming, then continue skips that work when it doesn't need to be run. So continue and break give you two very useful ways of controlling how the loop runs outside of simply the iterator variable in the sentinel value. Okay, so what we've learned so far, just to sum that all up, is that we have iterators and sentinel values, which let us decide when the loop will start and stop. So we start off with an iterator equal to some value, and we run it until some other sentinel value. So that just determines how far it will run. Generally, that involves some iteration statement like myFactor++. And we also know about the break statement, which, if you hit it, causes the while loop to simply end. That gives you a way of ending the loop independent of the condition that we've got here in the while loop. And finally, the continue statement, which gives us another way to run to the next iteration of the loop without performing calculations that we don't need. Okay, so I told you in the beginning that there would be three kinds of loops. I showed you the while loop in the beginning because it's the simplest. The while loop looks very much like the if statement, and the if statement is something that we've seen before, so that's good. It's important to know that the while loop can be used to substitute for the other two loops. So given any do while loop, I can write the do while loop as a while loop, and I can write the while loop as a do while loop. I can use any loop to replace any of the other two loops. The reason why I have these three is because the design of the code that I want to write is sometimes more convenient with one loop as opposed to another. And we'll see that here with the do while loop. So the do while loop has its own syntax, just like the while loop. It starts with the word do, but then is immediately followed with the curly braces and statements inside the body of the loop. After the curly braces, you follow with a while and a parentheses, which is a condition. The way the do while loop works is that first, after you hit the do statement, you always run the body of the do while loop. After you run the body of the do while loop the first time, then you check the condition to see if it should run again. If it should run again, if I is indeed less than 3, then it runs again. Otherwise, it doesn't run. So you can see how that's sort of like a while loop flipped on its head. A while loop always checks a condition first, and then runs the body of the while loop statement. The do while loop always runs the body first, and then checks the condition. That's simple, but when we see these two things together, you can see why sometimes you want to write code one way and sometimes you want to write code another way. So, for example, if I wanted to have a scanner object request something from a user, then one nice way to do that would be to have the scanner object make that request, like scanner.nextDouble. And if the input that the user typed in was not a double, you could have it scan again. That fits naturally into the do while loop structure because the do while loop structure always runs that thing first and then checks to see if it should run again. If you had to do that same thing with a while loop structure, then you'd have to have extra code. You'd have to have a copy of that body, that do while body run once just by itself. And then you'd have to have the while loop to run the rest of the body again. So first, get the input from the user. While that input is not okay, run it again. And that makes more code that isn't necessary to have in your software. So the do while loop sometimes allows you to write less code in a way that's intuitive. That's why we have a do while loop and a while loop, even though you can make one do the same. You can make two that you can make do while loops that do exactly the same thing as a while loop. The other kind of loop that we need to know about is the for loop. The for loop lets the programmer control exactly when an iterator starts and stops, specifies a sentinel variable, and controls the iteration, all in this compound statement here in parentheses. It's the most popular kind of loop. And the reason why it's the most popular kind of loop is because this control that you have inside the for loop statement conditional thing is really powerful, and you don't have to write a lot of other loops if you write a for loop most of the time. So one characteristic of the for loop is that it defines its own iterator variable, and because it defines its own iterator variable, it's kind of a self-contained thing. Like when you make your while loop, you have to have an iteration variable defined for them, right? You need to say int my factor, an input value, and then you can write your while. But the for loop doesn't require that. The for loop has its own iteration defined inside this compound component of the for loop. So because it's self-contained, and because it works with a kind of logic that's very flexible, for loops are probably the most popular kind of loop. That said, they're a little bit weird because they have this strange triple statement inside the parentheses, so they take some getting used to. But I think after you get used to them, they're pretty common. So how exactly does a for loop work? So for loop starts always with the for statement, and then it gives you an opportunity to initialize variables. You can actually initialize more than one. You can Google how exactly to do that. It's not unusual. You can initialize multiple variables, and then you also state what is the condition for iteration. So in this case, it's like I less than 5. And if the initial statement is the initial statement and the conditional part of the statement results in the conditional statement being true, then you can run the body of the for loop. And once you've ran the body of the for loop, then you run the iteration, and then you recheck the condition. So this looks a little bit unusual, but again, let's see how this works. First, we run the initialization. This happens at the very beginning of the loop. Then we test the condition. If the condition is true, we run the body. After we run the body, we run the iteration, and then test the condition again, run the body, iterate, test the condition, run the body, iterate, test the condition, and so on and so on. So this is very much like a while loop, really. It's really like a while loop that has its iteration variable defined inside it, and its iteration just defined inside it. And because it has it all defined inside it, you have a tendency to not forget those things. And that also makes it slightly less prone to bugs. For example, one thing that's really easy to forget in a while loop, excuse my flipping slides here, one thing that's easy to forget in a while loop is this iteration statement inside the while loop. It's usually like at the end of the loop somewhere, right? If you forget that, then the loop can accidentally run forever. The for loop prevents you from forgetting that because it's in the very beginning of the loop. You can't really forget it. So this is what makes the for loop really different from the do while loop and the while loop. But because it's self-contained, it's a popular thing. So just so that you have a name for everything, remember that the first component of that parentheses statement is called the initial statement, or initial setup, or initialization of the for loop. And then it has a testing condition. This conditional has to be true in order for the loop to run. It evaluates the test condition before it decides to run the body of the for loop. And finally, it increments after it runs the body of the for loop. So this increment only runs after this code has run. It's useful to know that because if you break out of a for loop, then the increments will not run because you've broken out of the for loop and you haven't touched the increment. Yes?
So if you're writing a for loop and you have sort of this pre-existing list of data and you want to iterate over each point in that, how do you write a test for that? Because it's basically like, does the data exist or not?
Well, the pre-existing list of data is not something that we have in the class so far learned. So that's not something that you can say exists or not. So there's something called an array, which we'll learn towards the end of the class, which once created, you can determine if it's been initialized or not. But if you have just a series of variables, you won't be able to refer to them in a loop. And maybe that's the issue that you've noticed, that if I have, like, say, strings named name 1, name 2, name 3, name 4, how can you refer to them sequentially inside of a loop? And the answer is that you can't, because they're distinct variables, and you have no way of saying, well, I want to look at the next string, because they have no relationship like that. The array takes that away, but we'll learn how to do that after the second exam. Any other questions on for loops or do-while loops? Yes?
On the slide it says the scope of the variable is inside the outside scope. Like, what is that? Can you explain that?
Oh, yes. That's in here, right?
It's like the, yeah.
Yes, so variables declared for the initial state, like int I equals 0, exist in the exterior, the scope outside the for loop. I'm a little bit concerned that that's not true. We have a few minutes. Let's test that. Okay, so while that sets up, I'll continue. Okay, so these are the three diagrams that I always show people for loops. And it's critical to understand how these loops are different. One of the things that I will be certain to test you on, and also that you should be certain to understand the difference between, is the difference between while loops and do-while loops. They seem very, very similar. After all, you have a condition, you run the loop, or you run the loop and then you test the condition. It seems really similar. But there are ways that I can make you write a do-while loop that force you to add things like an if statement in order to have the same effect occur. So for example, when I run this while loop, right, if test is true, then run statement. It runs test, statement, test, statement, test, statement. If I want to translate this into a do-while loop, then I have to somehow get the test to happen and then run the statement. So for example, if the test is false, the statement never runs, right? If a while loop has a false test, then it just simply goes right to the end of the while loop. If I want to reproduce that with the do-while loop, I can't get that to happen, right? The statements will always run the first time. So in order to prevent that from happening, I have to insert an if statement above this, like if test, run this do-while loop, otherwise skip it. That requires you to add some additional code in order to cause the do-while loop to run like the while loop. So be aware of that difference. Likewise, if you're translating the while loop into a for loop, you need to make sure that the starting and the testing and the incrementing conditions are identical between the for loop and the while loop. Similar deal is true for the do-while loop and the for loop. So while these loops can be made to reproduce each other exactly, you have to be exactly aware of what modifications you need to make in order to get that to happen. And the first way that you can be aware of that is thinking about these diagrams. Like the while loop starts with the test and then it runs the statements. The do-while loop runs the statements and then hits the test. If you need to make the do-while loop do what the test does, then somehow you have to get a test up here before you hit the first statements. That means inserting an if statement. Similar things are true for the for loop. So have a look at the old exams to think about how you might make these translations. The reason why I have you go through this exercise is not because software developers everywhere are constantly translating for loops into do-while loops. It's because it helps you understand how they work exactly, and in particular how they can operate in very strange ways. Okay, so the question is the initial initialization variable in the interior or the exterior scope. So this is a for loop. I'm going to print out the variable of I, just so that I see how many times it runs. If it's inside the scope of the loop, then this should be a compiler error, right? Because I'm attempting to refer to a variable that is theoretically inside the scope. So if it's inside the for loop scope, then this should be a compiler error. If it's outside the for loop scope, then this should not be a compiler error. Right? So let's see what happens. Not a compiler error, the slide's wrong. Good question, thank you. So, oh, it's in the outside scope. I thought I said it was in the inside scope. Okay, so it's in the outside scope, and that's why this does compile. So this side is right.
But something initialized inside of for loop would be.
Yes. So if this was like int k equals 5. This should not compile. Yeah. Good questions. Yes.
If you wanted to run another for loop immediately afterwards and still use the same variable I, will it then just reset it and then there will be no problems? Or
That's a great question. So the question is, if I want to run another for loop after this, will it reset? So first of all, it's going to have a problem with this. Because this is trying to initialize a new variable in the same scope that has the same name. So you can't have that, you need this. And what's nice about the for loop is the fact that that initialization phase allows you to reset I equal to 0. So here, I is currently equal to whatever it is at the end, it's equal to 5. And if I don't have this initialization step, then this part won't run at all, because I will be equal to 5 and I will not be less than 5, so the entire loop will not run. So if I assign this I equal to 5, or I equal to 0, excuse me, then it will rerun the loop. But you do have to reset it back to 0. Good questions. Yes?
How do you increment something more than one?
How do I increment more than 1?
By more than one, yeah.
Oh, by more than 1. Oh, okay, so if you have to increment by more than 1, then you would do this. I is equal to I plus 5. So this command here is identical to assigning I to I plus 5. Yes.
Couldn't you also just do I plus equals 5?
Yes, you can also do I plus equals 5. In fact, that's a little bit more elegant.